how to represent an irrational number on a number line? Irrational numbers. The simple example for an irrational number is root 2. We know that. Now let us represent plus root 2 and minus root 2, plus root 5 and minus root 5 on number line. You come across this type of questions in your 9th class, isn't it? Okay, good. Now let us represent root 2 minus root 2 plus root 5 and minus root 5 on number line. Again, as usual, let us consider a straight line and let us name this as number line. And on this number line, let us keep points at equal distances. Understood? Now, the middle point is 0. You consider the middle point as 0. On the right hand side to 0, you keep 1, 2, 3 and so on. And on the left hand side to 0, you keep minus 1, minus 2, minus 3 and so on. Understood? We located the positive values and we located the negative values also on the number line. Later we have to find where this plus root 2 lies on this number line, and we have to find where this minus root 2 lies on the number line. In order to get it, you may draw a perpendicular lines at plus 1 and minus 1. Understood? To draw a perpendicular line at plus 1 and also as well as at minus 1. We may recollect Pythagoras theorem once. Pythagoras theorem. What this Pythagoras theorem states, in a right triangle, hypotenuse square is equal to side square plus side square. Understood? Pythagoras theorem. In a right triangle, hypotenuse square is equal to side square plus side square. Only hypotenuse is equal to root over side square plus side square. Let us use this knowledge to get root 2. If we join this point 0 to this end, then it becomes a right triangle. In this right triangle, this side is equal to 1 unit as the distance from 0 to 1 is 1. And also we draw this line segment with 1 unit only. This is 1 unit and this is 1 unit. Then in this right triangle, this is right angle. This is the side 1 unit and this side length is also 1 unit. Then what is hypotenuse? Hypotenuse is equal to root of side square plus side square. That is root over 1 square plus 1 square. 1 square is 1 plus 1 square is 1. 1 plus 1 is root 2. Therefore, the length of this hypotenuse is root 2 units. Similarly, the length of this hypotenuse is also root 2 units. Understood? Now, what to do is, let us keep the point of the circular at 0. Let us keep the point of the circular at 0 and stretch the circular up to this point and draw an arc like this. Understood? Keep the point of the circular at 0 and stretch the circular up to this point and draw an arc like this. Like this. You draw an arc like this. This arc may cut the number line at a particular point. Similarly, on this side also, you keep the point of the circular at 0 and stretch the circular up to this point and draw an arc like this. This arc may cut the number line on the negative side also. Now we know that this length is equal to root 2 units and this length is also root 2 units. Therefore, the distance between 0 to this point of intersection is root 2 units plus root 2 units, and the distance between 0 to this point of intersection on the negative side of the number line is minus root 2 units. And later we will draw, later we will sketch to find root 5 and minus root 5. Root 5 is nothing but 4 plus 1, isn't it? 5 is equal to 4 plus 1. 4 means 2 square. 2 square plus 1 is 5. Therefore, on one side of the right triangle, you take it as 2 units. From 2, you draw a perpendicular line whose length is equal to 1 unit. And on the other side also, from minus 2, draw a line segment of length 1 unit. Now, as we did in the previous case, you join this point 0 to this end. Similarly, he join this point 0 to the other end. Now this is the right triangle. This is another right triangle. In this right triangle, this side is equal to 2 units. From 0 to 2, this distance is 2 units. Therefore, side of this right triangle is 2 units. And the side of this right triangle is 1 unit. Then the hypotenuse is square root of side square plus side square. 2 square is 4 plus 1 square is 1. Therefore, it is root 5 units. Understood? The length of this hypotenuse is root 5 units. Now, take the circular and keep the pointer of the circular at 0 and stretch the circular up to this point and draw an arc like this. Draw an arc passing through this point like this, so that it may meet the number line at a particular point. On the other side also, you keep the pointer of the circular at 0 and draw an arc which passes through to this point, may cut the negative side of the number line at a particular point. And this is minus root 5. Clear? Is it clear now? This is plus root 2 and this is minus, this value is minus root 2. Later, this is plus root 5. This point is plus root 5. And on the other side, this point is minus root 5. Plus root 2 and minus root 2. Plus root 5 and minus root 5. So that we located the given irrational numbers like root 2 minus root 2 plus root 5 and minus root 5 on the number line using Pythagoras theorem. Okay, thank you. Thank you one and all.